Let me just jump in and show you what this does, and then I can explain it in more detail. Um, so chat interface, pretty straightforward. Uh, So I've kind of given a statement of what I wanted to do. It's going to suggest what our overall goal is. It's going to come up with some potential steps. For now, I'm just going to say, that looks great. Let's keep going. And here's kind of where the fun starts. There's a bunch of stuff that's about to pass on screen. I will describe it in more detail once it's done. But essentially, how do we take user intent, clarify that, and then from that build a node graph that can be used in some of these workflow automation tools? Specifically in this case, I'm going to be using Magpie. I'm friends with the founder, and he was kind enough to give me access to stuff under the hood, which makes this a lot easier to do. So there we go. So let's copy this and paste this in here. Upward demo. And then we'll jump back across here. And then we'll import that. Okay. So what just happened? Basically, we have an agentic workflow that takes a user intent, clarifies what it wants to do, and then it goes off and it figures out which nodes it needs to build a workflow that runs in Magpie. So you can see here that it has brought in that URL that I mentioned. Actually, it's used something slightly different. It'll scrape it if it needs to. It's done a summary by using a LLM, in this case just ChatGPT. It's then converted that text into speech, and then it's exported an audio file. Real quick, let's talk a little bit about what Magpie is. Magpie is a workflow automation builder, no-code builder. So if I come back to the dashboard, you can basically create and store these different workflows, everything from kind of pulling data from Google Sheets or other kind of data sources, doing something to it, and then outputting something. You can also use it for image composition and modification using Gen AI models or other things. But I think we've been seeing more and more of these kind of things showing up where you're now able to create these complex flows using no-code visual coding tools. And the whole reason I've created this agentic workflow is two reasons. One is I've worked with node-based editors in the past. I've worked in visual effects using something called Houdini. I've used it in game development with Unity and Unreal. And I think we're starting to see a lot more AI-specific no-code builders, Make, Gumloop. There's a whole bunch of others. We've got Zapier. The thing that I've found, though, is with any of these tools or these apps, is there's so many things that you can do that it's sometimes difficult to know where to start. I mean, even just within Magpie, if we kind of look at all the different categories of potential functions and nodes that we can run, each of these has a whole selection of things. And as a beginner or a new user, it's really difficult to figure out, like, what do I have access to and how do I use it? And so the thesis for this was, is there a way that we can use AI to get us started, to get over that initial hurdle, to kind of help the onboarding process of, I know what I want to do, that's why I've come to this tool, but instead of me having to build the graph initially, let the AI build the graph, and then from there I can tweak it, modify it, do whatever I want to do. But it just makes it a lot easier and quicker to get to that kind of first draft of what my intent is, and then we can start messing around with it. So that was kind of the one reason for doing this. The other reason is I just wanted to kind of have something to learn about agentic workflows on. I think agents have become really popular as a term in 2024, but there's still kind of this question of what are they good for, where can they be used, what are their limitations, and this was a project for me to kind of learn that. So hopefully that's enough to kind of give you an idea of where we're at. I'm now going to run you through how essentially I built this. And I'm doing this because I think there is something in here that can be applied to almost any DAG related application. So if you're building direct acyclic graphs or these workflow automation graphs, I think the techniques that I'm using could be applied to all of them. And I'd love to see this being incorporated because I've had a look at some of the workflow automation apps are incorporating AI. And I'm going to call one out specifically, like Zapier added an AI integration in the last couple of months, which I think helps you find specific functions, but it doesn't really help you build an entire workflow. Like I think that's really what we need for something like this. And so that's part of this. And this is also just me learning. Like I've learned a lot of stuff along the way. And now I'm definitely rambling, but I'll say this much. I don't think anything I'm going to show in this video is novel necessarily. It's really me just kind of assimilating and combining the things that I've been reading and learning over the last 6 months around AI, Gen AI, agents, a little bit of RAG, and kind of what it can come into. Okay, so we've run a sample workflow. I've described briefly what Magpie is. I'll show you one other graph because I showed this in a Twitter kind of thread as a teaser. But just to give you an idea of kind of the breadth of what this can do. Like the one that I just showed you now was dealing with text-to-speech and LLMs for summaries. So this is just a compositing network, essentially. What I showed you before was more text-to-speech, LLMs summarizing text, web scraping. This is more image-based, so using generative AI models to create images and then compositing ideas to over one image over another or removing backgrounds, that kind of thing. So Magpie has a lot of different things it can do. And I think at this count, there's something between 200 and 300 nodes or functions available to the users. So again, it can be quite overwhelming for someone who's just getting into it. Okay, so that's Magpie. I've kind of spoken about the motivation. Let me go through how this system essentially works at a high level. And just to note, I'm not going to be showing a lot of code. I'm not going to go line by line through code. I think there's two things that are really boring for a video. One is watching someone using a chatbot, and two, coding. What I'm going to do here is show you a kind of high-level overview of what the steps are, how the pieces kind of come together, and then I'll be sharing the code. So if you want to dive in and kind of see how it works at that level, or you want to modify it, please, by all means. But for now, let's kind of focus on how these things fit together. So, super simple. The first thing that we want to do is clarify intent. So the user has an idea, which they put in through a chatbot or through a chat interface. And what we want to do is make sure that we're clear about what that initial statement is. So instead of just jumping straight in and doing something with a statement, the chatbot is set up to ask questions to clarify so that it can meet certain criteria before it moves on to the next step. Once those criteria have been met, then we can go to the next step. And the next step is generating a graph. the graph essentially is a collection of nodes or functions, and any values that would be changed that are not default, and then also an array of connections between those nodes that represent this overall graph. So it's going to do that phase, and then finally what we're going to do is validate the graph. It's checking for things like is there only one connection between one node and another node? Is it connecting the right type to each other? So if one node outputs an image, that should go into an image input. It shouldn't go into a text input or a number input. It's also checking to see that did the final result from generate graph meet the goals and criteria that we had clarified in the first phase. And then once it's done all of that and we're happy with it, then we output a YAML file. And that's what you kind of saw me do there, which is this file, which then represents what the graph is. And thank you to Ben for adding this. But essentially in Magpie, you're able to then import a YAML file in this particular format, and it'll do that for you. That's the kind of thing that could probably go away once this was embedded. Yeah, so that's kind of high level the stuff that we're looking at. It's these phases. I'll talk more kind of towards the end about maybe some of the routes I went down that didn't work out, but I think it might be even in this file. I've been playing with this for a while, and I've tried a bunch of different things, and I've tried different ways of breaking this down, and some of them have been more complex than others. So this is where I've settled for now, but just so that you know, this was not where it started. Like, it's definitely kind of expanded and then contracted and settled on this for now. Okay, so let's see. So those are the basic steps. The next thing I want to show is what I'm going to call the boring stuff. There is some element of the text and the code that I think is useful for you to be aware of, so that you know how this kind of system fits together. And then we can kind of get on to other things. So the first thing that I want to point out is, like I said, Magpie has about 300 nodes in total. These are functions, and they are represented as JSON. So I can jump up across over here, and so this is the entire library of nodes that are available within Magpie. And this is how they're structured. So every single node or function has a unique ID, it has a name, and then it has a bunch of metadata associated with it. The thing that I care the most about within something like this is the description, and I'll talk more about that later. And then what it also has is the inputs and the outputs. So it's the name and the type. So this is all strongly typed, which I think is quite important. It also has a default value. So initially when I got this, I realized that it was going to be a challenge to figure out how to get this into an LLM to make use of it. And immediately RAG came to mind. And like I said, I'll talk more about that later. But for now, I just want to kind of show you the data that we're dealing with. So this that you're seeing right now is just a single node or function. And there's quite a lot of stuff going on there. And we have this for a lot of different nodes and functions, pretty much everything that is in here. I know JSON has become quite common and popular for tool use and function calling, but I didn't think it would be the best way to approach dealing with stuff directly within a prompt. I wanted something that was human readable. I wanted something that I could easily debug and kind of make sense of. And so I ended up choosing YAML, which is pretty easy at this point, I think, to move between YAML and JSON. JSON is great for kind of back-end storing stuff, and YAML is great for storing it in a prompt or reading it. But this gives you an idea of kind of a piece of the data. So now that we had that, what I needed to figure out was how is it going to represent the graph, I've mentioned to you already that a graph essentially is a bunch of nodes with connections. It's not that dissimilar from something like this, where you have a node and you have connection, but you might have multiple connections to a single node. And we also need to keep track of the type of the input and the output so they connect together. And I can't really take credit for this, because I basically went to ChatGPT and I asked it, like, is there a format that I could use that would represent this, that was human readable and concise and a bunch of other things. And what it came back with, I think, is really interesting. So there's two pieces to this. The one is the node schema specification. By the way, I know that Magpie, for instance, is using React Flow. I think React Flow, if you're not aware of it, has become very popular for building these node-based web applications. Comfy UI uses it, and a bunch of others as well. I think Gumloop uses it. And the way that React Flow represents the graph is an array of nodes and an array of edges in JSON or JavaScript sort of objects, which is fine for code, but I wanted, like I said, something that is more human readable. So I'm aware of that. It's not that I'm ignoring that. I just wanted something that was a bit more friendly. And so, yeah, I had this chat with ChatGPT, and this is what it came back with after a while. And so I want to kind of show this to you, because I think what's kind of cool about this is the simplicity of it, but it captures a lot of the important information that we can then use later on. So the first thing that I wanted to do was convert this JSON that we see over here into something that's more compact. There's a lot of stuff in here that I do not need for the purposes of feeding into an LLM. And so this is what we came up with. So this is a YAML description. It would be node types is the key, and then we'd have a list of nodes, and each one would have an identifier. So this over here, this node type identifier, would be the same as this over here. It's unique to this node or function. We then also have a list of attributes, and that can be the name, the type, anything else that might be important, description, and then finally inputs and outputs. And purely to kind of, again, compress and keep things simple, the only three things that I kept were the ID of the input, which essentially is the name, the type, so that we could make sure that we were connecting things together, and then a default value, so that I could check against that to make sure that when I was generating a graph, it only generated a graph with values that needed to be changed, rather than repeating default values that were not necessary. So that was the first part. How do we represent all of this in something that's human readable and then can also be passed into a prompt? And then the second part of this is, how do we actually represent the graph? And this is very similar, but I really enjoy the kind of simplicity and conciseness of it. We have two sections to the YAML code. We have the nodes, which is going to have the ID, and again, that's just going to be this name over here for the function of the node. Sorry, I get these two confused. That would be the node type. The ID is a unique name within the graph representation. You'll see it in a second, kind of more of that. If a value needs to be modified, then we would include that in the input section. So simply the name of that input value, and then the value that we're going to include. This could be a string, a number, a Boolean, whatever. And then the edges section was source and target. So we want to go from our source node and the attribute, the output attribute for that, to the target node and the input attribute for that. And that's essentially it. This was the structure that I was using throughout most of this. And I think it's worked out pretty well. From what I understand, this looks or inspired by Dot. I only know this because this is what ChatGPT told me. But I haven't seen something that directly relates or mirrors this particular sort of setup. So maybe it's a good way for us to be doing this. I know there's been a lot of talk lately with a couple of people, TLDraw, XState, etc., on how to represent node graphs. I think Obsidian have also been involved in that, but that's a kind of a separate topic. But this is just to give you kind of a sense of what are we looking at in terms of data. Oh yeah, so that's the catalog of nodes, the node schema specification, and the graph representation specification. And just if you're curious, so if this is what we want everything to look like, and it currently looks like this, then let's see if I can find a file where I've actually converted it. Might be this one here. Yeah, so this will give you kind of the same thing where we've got basically the JSON converted to YAML and then stripped out and only representing the ID, the type, the name, the description, and then the inputs and the outputs. Okay, so yeah, that's that over there. Okay, so let's actually go through the breakdown of the steps. And since I've just spoken a lot about the schemas and the specifications, I'm actually going to start with talking about generating the graph, because I think that's kind of where a lot of this work happens. And some of the things that I kind of had to figure out along the way to make this work. I'm not going to show the full system prompt, not because I don't want to share it with you. You're more than welcome to go and have a look at it in the code. It's more just for the sake of this video. Let's look at like the high level pieces that make this all up. And if I haven't given you enough information, please feel free to reach out to me and I will clarify, or you can read through the code. But this is kind of now getting into like the prompt engineering that I did for this and some of the things that I kind of had to figure out along the way. So let's go across here. And no, we don't want that one. Yes, we do. TLDraw. That's it over there. Okay, so we'll talk about generating the graph. I'll come back to clarifying intent, but let's stay with like the schema specification stuff. So for the generation of the graph, we needed a couple of pieces of information. The first one was, once we clarified the intent, what we get from that is a goal, the key steps that would result in achieving that goal, and a summary of that as well, which I would argue the goal and the summary are kind of the same thing. So maybe that needs some refinement. The other thing that I want is a list of potential nodes that the LLM can use to generate the graph. So, like I've said already, there are about 300 nodes in here. I can't fit this all into the context length of the LLM, and I also don't want to. And I did try RAG, and I'll talk about RAG a little bit later, but for now, just be aware that we have a short list of somewhere between 30 and 45 nodes represented as YAML going into our prompt. We also have reference graphs. So one of the beauties of something like this is in Magpie, and you'll find this in a lot of these workflow automation apps. There's often a gallery of existing workflows. What I did was I converted all of those into the schema specification, and I had that as reference that I could use in this. So for instance, there's this Time magazine cover workflow, which is broken on here. I need to find a different version of it. It's not broken. I was messing with it the other day. But nevertheless, we've got these workflows that we can use as reference when the LLM is generating a graph. I feel like I'm clicking on a bunch of stuff that is not helping me at this point, so we'll close all of those down for now. And we will go back to this over here. And then the only other piece of information that I bring into the prompt is I have a base prompt. The base prompt is very simple. It is literally just you are a node graph builder that is generating graphs similar to the kind of things you would find in these other types of node graph builders. And that just got added to every single prompt. So that's kind of high level, the inputs that are coming into the prompt. Let's actually talk through like the how the prompt is structured and what information is in there that was able to then generate the graph. And again, starting high level, like how is the prompt structured? And then I'll go into some specifics. So I ended up using Claude because I think everyone's excited for Claude at the moment. I started using ChatGPT for this. I don't think it matters which one you use per se. I also wanted to kind of see what the difference would be between structuring my prompts as purely Markdown, which is more kind of the ChatGPT style, and also structuring them more towards the XML tag style that Claude and Anthropic suggest for their specific prompts. So I've tried both. They both have relatively the same results. I think this is more just kind of high level what's going on. So in every prompt to generate these graphs, I had the base prompt. I then had the node schema specification, which is this. This is literally the thing that was going into the prompt. What I'm trying to do is I'm defining what the LLM should be looking for and looking at, so it understands what the different pieces to this are. And that's kind of what this does. We define what all the different attributes are, as well as kind of what that code structure looks like. Then the graph representation schema, same idea. We want to be clear about what is this code, why does it look this way, what are the different pieces to it, so that it has some kind of reference to that as it's generating the graph. Then a list of available nodes. So this is the thing that I've definitely gone back and forth on a lot, but essentially it is literally just a YAML file that kind of looks like this. And the fun here is, I think still for now, is finding the balance between giving the LLM enough information to do what it needs to do, and not so much that it starts hallucinating and doing a bunch of other things. And so far, from my experience, somewhere between 30 and 45 nodes with this information seems to be a sweet spot. I could do less, but what I'm trying to do is provide not the exact nodes that I would use in the situation. I want to give a range of nodes that are in the ballpark of how this problem could be solved, and then you let the LLM decide how it wants to connect those up. And so that's kind of where this comes from. So that gets injected into the prompt. We then also put in the goal, and the goal is a single sentence or two. It's the key steps that it would take, as well as the summary. And if you want to see an example of that, let me go back to the first thing that I did over here, because I really did kind of sneak past this. You'll see that, there we go. So in this case, the goal was summarize an article about Twitter marketing tips and convert the summary to audio format. These are the key steps that it includes. And then this is the summary. So that gets injected into the prompt. And then we have a bunch of instructions and guidelines. I'll come back to that in a second. I will show that part of the prompt so we can kind of see, like, what are we asking it to do. And then finally an example. I know there's opportunity here to have multiple examples because of how much the LLM is generating. Again, I had to kind of manage how much I put into the context because what I'm not doing here is simple classification or kind of binary selection where I can include a bunch of examples. And so I did have an example of what I expected the code to look like, but maybe I could do more now that context legs are slowly, or they're increasing. But yeah, that's kind of what it is there. And this, if you've done any prompt engineering, this probably looks relatively familiar. Like the structure of the prompt overall is not dissimilar to what a lot of people have already suggested and are already doing, and we know kind of works. So let's talk about what's actually in instructions and guidelines and examples. Let's see. So this is the full prompt that goes in. As you can see, it's already pretty long, and this is not including the pieces that need to resolve. So I'm just using Python string formatting. So it's going to inject the base over here. It's going to inject the node list, which would be somewhere over here. There we go. So the node list, reference workflows or node graphs, goal description. But yeah, let's talk a little bit about instructions. This is currently Anthropic formatting XML tags, but I also have a version of this which is Markdown, for ChatGPT. ChatGPT also does pretty well with XML, I found, so I don't think it matters too much. But yeah, let's talk about the instructions, and I'm going to take a detour and tell you what I first tried and what didn't work. So if the final result that I want is going to look like this, then what I initially tried was just to have the LLM generate this directly. I thought that if I gave it a list of nodes that it would potentially need, as well as a goal of what I wanted it to achieve, that it should be able to produce the nodes that it's going to use and then how to connect them up together. But interestingly, there were a couple of things that kept on going wrong. Firstly, often what it would do is hallucinate the names of the nodes that were needed, which I thought was interesting. Interesting because it only seemed to happen in the earlier stages of how I set this up. The other two things that I think are more important with when I tried to just naively have it generate the graph directly was, one, it would not respect types of inputs and outputs. So it would try and connect a string output to an image input, which obviously wouldn't work. And so the graph was invalid. And when we try to import it into Magpie, it would fail. The second thing that it would often do is it would try and connect multiple nodes to one node to the same input, which in this particular case, in most situations, is invalid. It shouldn't be doing that. So it was interesting that that failed. And I've tried many different ways of structuring the prompt and the code and so on to improve on that, and it just never seemed to work. So let's go and use what we already know. We do know that React works, and so if you haven't seen it already, reason and act as a prompting strategy has proven really useful for more complex tasks. And so I use this as inspiration for what I wanted to do. I think the original paper, the idea was that the LLM would have a thought, it would then perform an action, it would run a function, and then it would observe what the result of that was. And so I wasn't directly running functions for the act part, but what I was doing was saying, can you add another node to the node graph? So let me kind of show you what that looks like. And we can come back over here, and I'll show you the example. So this is how I wanted it to actually go about doing it. So using Markdown formatting, just because it's nicer to read in a chatbot. I come back over here. Here we go. So the instruction was break it down, very similar to React, in multiple steps. And for each step, have a thought about what it is you want to do. Act on that, and act here meant update the existing node graph with either a new node or a new connection, or updating a value for an existing node. And then finally observe, like, tell me what you see based on what you've just done. And immediately the results were way better just by doing that. So that was kind of the first thing that we included in the instructions. And that's what I included in the example I show here. I want you to start with step one, have a thought. As part of your act, you're generating a part of the node graph, and then you're observing what the current state of the graph is based purely on the text that it is generated, and then repeat until it gets to the end of the process. I think what I'm learning more and more about LLMs is how powerful this idea can be, which is letting the LLM generate some information that it will then later use in the same generation process seems to really solidify what it's doing, and it seems to be a lot more consistent and robust by having it do this way. Okay, so yeah, that was basically what I said in the instructions was, identify the elements that we want to work through from the goal that was already specified, and then starting with each element. And an element could be an image, it could be a website URL, it could be a file. Work through building out the graph, and then once it's gotten as far as it can for that element, go back and start on the next element. And by doing that, it actually then connects things up in a way that is correct and needed for the context of the particular goal, which I thought was quite interesting. A couple of things that I put in the guidelines. I think, like any prompt engineering, guidelines are just going to be something you're going to go back and change and modify and keep playing with over and over and over again, same as the instructions. One of the things that I did in this case was, and I added this pretty late to this whole setup, but it's proven to really help quite a lot, is I said you can use the reference node graphs to help inform you about what to do at each step. So let's talk a little bit about the reference node graphs. What are they? I mentioned already that essentially what I did was I took all of the existing workflows that are available within Magpie, the community workflows and ones that I've made, and I've converted that to YAML. So to show you what one of those looks like, and also just to show you the list of them, they are over here, and I'll pick one which is relatively simple. Let's see, it generates an AI image. In total, there's about 16 of these, which thankfully is not so much that I needed to worry about RAG, but it is a number that can increase over time as we kind of start fleshing out the different types of workflows that you might generate. But what I want to show you here is kind of what is a reference workflow in terms of the text that's included in them. So the first thing is it's just the node graph in this YAML format, which is going to list out the nodes. So the node type, the unique name, any values that would have been changed from their default value, and then also the connections between them. What I did is another step to this, and I love the way that there's so many ways we can use LLMs now, is I took all of this and I fed it through another prompt that basically said, can you give me the goal, the key steps, and the summary? And so at the top of each of these is exactly that. It's the name of the workflow. the goal that this particular workflow is trying to achieve, and then the key steps. And the key steps are not calling out specific nodes or functions. They're calling out the process that node or function is going to do. And I think this is really helpful for kind of semantic similarity, versus kind of being very specific about which node to use, and then a summary. And so this is a reference workflow, reference node graph. So as part of the guidelines, and as part of this prompt, I would feed in 3 of these workflows, so that the LLM had something to look at essentially and see not only like what are the key steps and what is it trying to do, but also, what does this look like? So that was put in there. Initially, when I started creating this setup, I focused on compositing networks because my background is in visual effects, and so I'm more familiar with what can and can't go wrong in that space, and I thought it would be an easier space to try this out on. I've since learned that's probably not true because we're asking a language model dealing in text to interpret images, and this does not have any multimodal capabilities at this point. So how does it know if it is asked to create an image for the foreground and an image of the background, where to put the foreground image over the background image? I think it could be possible just with text, but I think that's where a vision model would do a much better job of providing feedback into a system like this. That's an aside. One of the things also that Magpie allows you to do is you can either import an image, so you can give it an URL, or you can upload a file, or you can use a generative AI model to generate an image. And because the whole point of this was to test out using more Gen AI stuff, one of the guidelines was let's favor the image generation nodes over importing. We also always wanted to provide a prompt for LLMs or for image generation. And so, yeah, a lot of these guidelines, I guess, were more around compositing than anything else. So, yeah, that's kind of what was happening in there. Okay, so, yeah, so that's kind of what was included in the generation phase. And this seems to be sufficient to get us, I would say, 85% of the way there of constructing a usable graph that can be imported into Magpie or some other system. And I want to be clear about this. I don't think that this is the kind of thing that maybe for now you want to use to completely replace creating node networks, or that it would be clarify the intent and the user is done. It's really kind of getting someone started, because I think there's still enough nuances in how someone wants to make changes to some of these nodes. So for instance, we'll come back to one of these examples where you might want to change some settings on a node or a function. And I don't think at that point a chat interface is the best way to go about it. I think you do want to use a UI that's going to be better suited to that. So I'm not trying to create a system that is kind of one and done. It's more, like I say, it's the onboarding process. It's the discoverability and learning process of dealing with node graphs. And it's the first draft kind of process. So yeah. I think that's everything I wanted to show there. Yeah, so that's the generation phase. So let me actually show you what the output of the generation is, because I kind of skipped over it really quickly when I was showing the demo, but now I can actually show it. So taking all of that information brought in, this is what the LLM generates. It generates the first step. It comes up, it has the thoughts about what it's going to do. And the first thing that it did was it just had a simple input string node set with these values. Interesting. Maybe Anthropic changed something in the last day or two, because this was in previous examples using the URL that I would set it. You can see up here I've used this, but I know that safety is a concern, and there are reasons for that. And there are ethical things around scraping as well. So let's just mention that. But yeah, so it's going to do the thought, act, observe, thought, act, observe. It's basically going to keep on going through this. At first I was concerned with how much text this was generating rather than just generating the graph. And maybe there is a way in the long run to reduce this through fine tuning, or trying to go back to the idea of just generating the graph directly. But for now, this is the most robust way that I found in order for it to do this. So it's going to do that. And then when it's finished, it's going to represent or present to me the final graph. And that's what's over here. So there's markdown formatting issues in here. That is probably why it looks a bit strange, but this is the thing that it creates. And so once it's done with that, we then go to the next phase, which is the validate graph. I will come back to clarifying intent, but I think this is sticking with the schema stuff. What do we want to look at over here? So validating the graph. There are probably a number of better ways to do this. The most obvious way to validate a graph, I think, is to use code directly in Magpie to give it a single node and its values, and check that against the way that a graph is actually constructed within the workflow automation app. Same for checking edges. Like, basically in the background, try and do that the same way as you would with code interpreter, and use the errors for that to feed back into the system to then improve and fix any issues that the generation might have. Purely for the sake of time, I didn't do that, but I think those are the kind of things that can be replaced. For now, what I want to focus on, like I said, for validation of the graph, was three things. Do the nodes exist? Are the types between connections correct? And is there no more than one connection between an output and an input in that process? And so to do that, it's very similar to the generate graph phase. We bring in our base prompt. I give the prompt the list of nodes used in the generated graph. I don't now give it any options about other potential nodes. I give it the goals, key steps, and summary from the earlier phase, and then I feed that into the system. So in terms of the validation prompt, like I say, it's very similar to the generate prompt. We're still giving it the schema specification, the graph representation specification, the list of nodes that were used, the graph that has now been generated. So if we come back over here, we give it this so it has something to work with, and then instructions, guidelines, and examples. And the way that I structured this is I basically asked the LLM to start from the end of the graph. So if we come back here and look at something like this, I asked the LLM to start with the end node and work its way back. And the idea there was to kind of make sure that the way that it was branching out and reconnecting and so on was correct. And I'm forgetting there was another reason, but why I did it kind of back to front rather than start from the top and work its way down. But it's, like I say, I think there's a number of different ways you could do validation. This was using purely just within an LLM, but I think there's a lot more robust ways you could do that with code to check these nodes. So yeah, if we just kind of see what it's done here, interestingly enough, in this case, let's see where the validation part starts. Yeah, so it actually starts over here. The graph fulfills the goal of summarizing the Twitter marketing. this is it going through each node. It's checking it's correctly connected, no issues found, correctly connected, no issues found, so on and so forth. If it does find an issue, it will update the graph, and then it will present the final graph to us. And that's what this is, and this is what I was copying over. Yeah, so that's validation. So let's talk a little bit about clarifying intent, because I have thoughts on this that I want to share. So let's jump back over here. And we'll go over here. So this has gone through a number of rounds to figure out something that works. And the things that I want to start by pointing out is what I'm doing here is I'm using Claude 3.5, ChatGPT 4.0, 4.0, whatever you want to do, with a function call. And the reason I mention this is because this is something that I think I read in the Anthropic docs initially, but both models and a lot of the state-of-the-art models do is if you include a tool use or function call as part of your response or your request, as well as something in the prompt that says only do this when certain criteria are met, then the large language model will not call the tool until that specific thing has happened. And the reason why this is cool is because if you use some of the faster, cheaper models like Haiku or 3.5, they are designed to basically, if you include a function call, it will almost always use the function call. And that's fine if you are doing data extraction or need structured outputs back. But the nice thing with this kind of system is basically what we're saying is, leave it up to the LLM to choose when to make that call. So to put that into something that's a bit more concrete, let's go and have a look at the prompt. And now you get to see the mess of the file that you will not be getting. I will be cleaning this up before I send this out and share the code. But it'll give you an idea of kind of what we're dealing with. So the prompt for this first section is relatively straightforward. This is it. So I've given it the base prompt, which is you are Node Graph Building Assistant. You help the user build node graphs similar to Blender, Houdini, or Nuke. Given a user query, list of potential elements, and a list of available nodes, generate a graph of nodes, blah, blah, blah. But then this is now what's happening specifically in this initial section of clarifying the intent. So your current and only task is to help the user clarify their overall goal and the potential steps required to achieve that goal. The steps represent a node or sequence of nodes that make up a node graph. If the user asks for other information or attempts to build a graph, gently guide them back to identifying the goal, the potential steps that satisfy this goal. That's all we're trying to do at this moment. You can use reference graphs to help inform which steps might be relevant. I'll talk about that a little bit later. We want to keep track of the overall goal and steps. If you're not able to discern the goal or steps, ask the user to clarify. Do not attempt to guess wildly. I think that's something that we're seeing more and more is really important for these smarter chatbot interactions. And then ask for confirmation from the user that the overall goal and steps have been identified. Only call the relevant tool when the user confirms that they are satisfied with the overall goal and steps that have been identified. So this is the key piece here. What's being fed into the system, hopefully I can show it here, like I said, without getting too much into the code, because I'll leave that up to you at some point. Okay, so this is the function call. if it looks a bit strange to you, I've got a Pydantic version because I like using Instructor where I can, but I didn't use Instructor for this. I actually ended up using Claudette, the fast AI implementation of Claude, which is just a nice little wrapper that keeps things simple. But this is the function call. It's looking for a goal, the key steps, and the summary. So this is what is being included in the request. But it's only going to use that if the user confirms that it can now do that. And I'll show you what that looks like over here. You might have noticed when I first started this, I said, hey, this is what's going on. It came up with a goal, it came up with potential steps. And then it asked me, is this understanding correct? If so, I can help you refine these steps further. If not, please let me know what adjustments are needed. And so it's only by me saying that looks great, please proceed, that it then moves on to the next phase. And there might be another way to structure this user experience-wise, but I think it's a nice kind of gated system by doing it this way. So thought I would mention that. I think this can be used more as a way to kind of decide how to structure your agentic workflows, using that way of doing it. Let's see what else we got here. So what exactly is in the system prompt besides that information? The only other thing really is the reference class. And I wanted to point this out as well because I thought it was kind of cool. So you'll see that the system prompt has the section over here. And this section is going to include 3 of these. These are these reference workflows that I mentioned before. And the way that I did this was basically, as you're having a conversation with the chatbot, after every message that has been sent by you, we take the entire message history and we send it to a separate LLM call. In this case, I'm just using Haiku. And what that call is doing is it's doing basically like a version of RAG, which is it's looking at the message history and it's saying, based on this message history, which are the 3 most relevant graph reference workflows? And it returns those 3, and then those 3 are put into the system prompt for every response by the chatbot. And you can see it doing this if we have a look on the side. So this is just a little bit of debug information. But because this is relatively short, I didn't really give it a lot of information. It actually only returned a single reference graph. And all I'm including in the system prompt is the description. So it's the goal, the key steps, and the summary. I'm not including the actual graph itself at this point. I don't care about that. I feel like I could explain that better, but I want to get this video out rather than spend days editing and formatting. So if I need to come back to it, I will, but I will try and summarize that again. So in our clarify intent section, the user types in a message. We take that message and any history and we give it to a separate LLM response and we say, what are the 3 most relevant workflows that already exist in our catalog that match or look similar to what the user is asking for? We get those 3 back, we put it into the system prompt part of the chatbot. And so that's constantly being updated. And the chatbot gets to respond by either asking a question or stating what it thinks needs to be done next. And we stay in this loop until the user says, I'm happy with where we're at, please proceed. And so the beauty of that is that at any point the user can say, I want to change the goal, I want to add or remove a step, or I want to go in a completely different direction. That all kind of works just fine. And then when it's done with that, it then goes and it saves and extracts the goal, the key steps, and the summary, which then can be passed on to the generate graph phase. again, trying to keep this high level rather than getting into the code, but I don't know if it's necessary to see the code for this to fully make sense. Maybe what I'll do before I get into the last section is let's actually just run this one more time, and you can kind of see some of this playing out. Please forgive my messy code. It will be cleaner when you get to play with it. But yeah, let's do this real quick. Okay. So now you have a rough idea of what's going on. We have a clarify intent phase, we have a graph generation phase, and we have a graph validation phase. So we're currently in the clarify intent phase. Let's just kind of see what happens in terms of the messaging. So okay, so this is pretty straightforward. It's going to just recite back essentially what's in the system prompt. It's happy to clarify goals, identify key steps, and kind of how it might go about doing that. And then explains, once it has the necessary information, we'll move on to the next thing. So let's go with the image composition side of things. This is an example I've been using throughout this process, so it maybe makes less sense to you. I'd like to make a birthday card for my mom. She likes yellow puppies. Okay. So it's sending this off to the side LLM, where it's going to look for relevant workflows that kind of match this problem statement. And that's what you're seeing over here. So it has found 3. It's found a generates an AI image workflow, AI YouTube thumbnail workflow, and an AI stylized pie chart workflow. And then what you're reading here is just a subset of the data. Like I say, this is more for debug purposes, but you can see here this workflow creates a user-friendly interface for AI image generation, allowing customization of the prompt while maintaining preset parameters for consistent high-quality output. So this, again, is just giving the chatbot something to work with. And then once it has this, it's going to respond to this statement that I made. So let's see what it had to say. Great idea. That's very much Anthropic style at the moment. Lots of positive affirmations to whatever you do. I guess ChatGPT does that as well. They all kind of have that need. So let's work on clarifying the overall goal and identifying the key steps. Based on what you've told me, here's what I think we want to do. Overall goal, create a personalized digital birthday card featuring yellow puppies for your mum. And here are the steps that it's going to take. It's going to generate or import an image of these puppies. It's going to add a personalized message. It might apply some filters, change the layout and composition, add some decorative elements, and then finalizing the card. And then it's going to ask me, is this kind of what you're looking for? Does that match what you want to do? Again, it's not going to move forward beyond clarifying intent until this step has been completed. So I'm going to make some changes here. I'm going to remove, don't worry about distic filters or effects. And can you generate the image of yellow poppies? Because I don't have one. So again, off to the faster, cheaper LLM. And you see that has now updated on the right here. These are now the 3 reference workflows that are being passed into the system prompt for the chatbot to use as part of its response. Interestingly, we've now gone for a social post workflow, the Time Magazine one, and then a stylized pie chart. And so let's see. Thanks for the clarification. Here's an updated version. There's the goal. Here are the key steps that are going to take. And are we happy with where that's at? So that's kind of this first phase. And I think there's a lot in there that is really useful. But that's kind of essentially what it's doing. Hopefully that gives you enough as to what that initial phase is. So I could say, that's great. Please continue. By the way, there's some things in there that I probably wouldn't want it to do because I know that there might not be something on the node graph side that allows it to happen. But nevertheless, we run through that. Let's talk a little bit about this node list that I mentioned. So while that's doing its thing, I said that for the generate graph phase, we give it a short list of functions that it can use. And that shortlist is made up of two pieces. It's made up of a hand-picked selection of nodes that I always give it to generate the graph. And that's because these are the things that I found were just common to most node graphs. So instead of relying on the system to try and figure that out, I just immediately include that. And then I think it has about 20 nodes or so. Then what I do is you would have noticed there that we had these 3 workflows that were given as reference. I take the nodes that were used for each of those workflows and I add it to the handpicked shortlist of 20 nodes. And that's how we get to about 30 to 45 in total. And that's then the selection nodes that the LLM has to choose from when generating the graph. And so yeah, it went off and did its thing. You can see that if we come up over here, we start by doing a image generation of yellow poppies. It even does the prompt for that that node. It then also does a remove background node because I'm going to composite this with something else, so it adds that over there. It then goes through and, interestingly enough, creates a gradient, a radial gradient for the background, which is what the yellow poppies are going to go on, and so on and so forth. So it goes through the generation phase, it then goes through the validation phase, and then we get this at the end here. So let's actually see what this looks like in Magpie. So let's add this over here. We'll go to output. Okay, and then we'll come back over here. And let's put it in this one. Okay. Now, this is going to break in a number of ways, and I think this is where the system is not bulletproof yet. But I will throw it in there so we can kind of at least see what's going on. Okay, so we've got our image of the yellow poppies. I might just need to run that. You'll see here's this radial gradient that it created. Hopefully that works. It does. This might not work so well, but let's give it a try. Hopefully it removes the gray from this. There are different remove background functions available in Magpie, and then it's going to composite these together. So we do that. We then add the text message, which is this over here. Interestingly enough, that didn't work. I'm not too sure why. Yeah, something to look into. But that's not a bad first start for something that someone who is not familiar with node graphs or what's possible could then kind of go through and start playing with how this stuff all fits together. Yeah. Okay. So yeah, that's the gist of this system. Love to hear if you have any feedback. I am providing this to be used freely. If you work for a company that does create these workflow automation apps and you want to inspect this and implement it and integrate it, that would be awesome because it would validate that I think this has usefulness. So let's talk a little bit about some of the other pieces to this that I think are worth bringing up. So I did that. Yeah. Okay. First thing I want to mention in terms of like miscellaneous, when I started this project, I wanted to learn about agentic workflows. This was probably in like February of this year. And at the time, and I would still say at the moment, there aren't that many agent frameworks out there for people to use. LangGraph, I think, is the most well known because of LangChain. There's Crew AI, Alarm Index has something, XState or Stately has a framework around that as well. Microsoft's, I forget the name. Point being, I needed to pick one. I needed to use it, see how it goes. And so I picked LangGraph. I figured I would go with the one that had the most kind of community support and had been battle tested. And I will say that LangGraph is a fantastic product in the sense that it is at the moment. My personal grievances, I think, are against LangChain. I think LangChain has become very popular and exploded in use very quickly. And I think because of that, there's a lot of abstraction to what's actually going on under the hood. And when I'm learning, I find that really difficult. So I started this project in LangGraph using LangChain for the prompting and extracting data, and Langsmith for tracing and observability. And I eventually moved over to just doing Python kind of, I wanted to be as bare bones as possible. So when you look at the code, you'll see that I ended up using Claudette just because it was new and simple and it wrapped Anthropic's Claude. And everything else is pretty much just Python. And I think what I've learned is that depending on how complex the system is you're building, that's probably sufficient. LangGraph can do a lot of things, as a lot of these agentic frameworks can, but I think sometimes we can get away with just doing kind of if-then statements or just having kind of basic logic for switching or whatever else it might be that doesn't require another layer of abstraction. I might go back to using LangGraph in the future, but I probably wouldn't use it with LangChain. I think more of my concern was around LangChain and how it was difficult sometimes for me to understand what was going on under the hood. So I want to point that out, that I still don't think we have enough players in the field or enough history for these frameworks to say that one is better than another. I think you just have to pick one, give it a try, and keep going. So putting that out there. I mentioned Claudette. I ended up using that for the wrapper for Claude. It's really cool because it's really simple. Couple of things that I would change about it. The one is the way that streaming is currently handled, and then also extracting structured data from tool calls. And yeah, maybe that's a separate note. The other thing I want to talk about is RAG, because it's another part of this world that kind of you end up becoming involved in. Part of me doing this project was to figure out I want to learn how to use RAG and when to use RAG and what the different ways of doing it are. I think there's now so much good information on the internet about it if you're new to this space, which is great. And so the first thing that I tried to do actually when I set this project up was use RAG to go through this list. So initially the clarify intent phase would try and identify which nodes were most relevant to the user's intent. And the way that I try to do that was by using the ID and name of the function as well as the description, and immediately ran into some issues. On the purely on the data side, one of the issues was this was made by a single person who was trying to build an entire product. And so a lot of the descriptions were either lacking in being descriptive or not there altogether. And so I found myself going back and updating a lot of the descriptions so that I had something that I could use in a vector database with embeddings that would be more useful. I naively thought that that would be sufficient for me to have a user query and then match that user query to the node, or match a key step to a node. And what I found was the results just weren't that great. I did re-ranking. I did a little bit of keyword search with vector database search, and no combination of that really gave me what I was looking for. So the next thing I looked at was tags. Was there metadata that we could use to better identify which nodes we would need for each of these key steps? And basically what I came down to was the problem that I was trying to solve required a different way of approaching this. What I needed was context for what an entire graph would look like, which is why what you've seen is what I settled on is, can I come up with a goal and some key steps, and can I match that to a workflow? Because one of the things with these node function setups is the node on its own often isn't the key piece of information. It's the context that it's in. It's how we combine multiple nodes together that gives us the result that we want. And so a node can have multiple potential implementations or use cases. And so on its own, it's not really descriptive enough about how it's going to be used. So I think that was kind of key lesson for me, is that I was trying to do kind of traditional RAG over this list and just never finding it would work. And instead what I went for is using a fast LLM model and a very short list of reference workflows, which is all of these. And so just by asking the LLM, based on what the user has said and what the key steps sound like they could be, which ones are closely matched. And that allowed me to then get a lot closer to coming up with a short list of nodes that I would use for generating the graph, rather than trying to identify individual nodes along the way. So I still think there's a lot of space to explore in how we retrieve and augment our generation that doesn't necessarily look like a vector database, or even how that kind of plays out. So just to be clear, I think this is part of my learning journey and limitations of experience in this, but I did want to share that I think there's a place for RAG in the system, like traditional RAG, but the way it's set up at the moment doesn't use a vector database, because I just don't have either enough data to warrant it on the reference workflow side, or it doesn't seem to apply to the list of nodes and the information that they provide. If someone has a counterpoint to that, or has a way to show how that would work, I would love to see it. I'd love to better understand how to do it that way. But for me, I wasn't able to get that to work. So that's RAG. And I think that's it, because I've probably spoken for a lot longer than I wanted to. But hopefully this is useful. This is an agentic workflow that generates node graphs for workflow automation systems. And I think this setup that I've come up with is general enough that you could probably use it for a lot of different node-based applications. I'd love to see someone try this with Comfy UI. I'd love to see one of the existing kind of startups see if this works on their side. And I'll probably keep playing with this in some other ways. Like I say, I come from a VFX background. I wouldn't mind seeing if this was applicable to using side effects as Houdini, because it is a very heavily node-based procedural system. Hopefully this was interesting and helpful, probably too long. And if you watched this far, thank you.